So my paper is on recent emerging techniques in explainable artificial intelligence to enhance the interpretable and understanding of AI models for humans by Mathew et al., published by Springer in February 2025. As AI systems become more complex, sophisticated, and pervasive in every aspect of our lives, they influence our actions by making decisions and recommendations we can't ignore. However, the challenge is that as humans, we want to understand how decisions are made and what can influence that decision in the future to convince ourselves that they were the right decisions, were fair and unbiased. Models like neural networks and ensemble models are not naturally explainable. So let's look at the aims of XAI. Explainable AI is necessary for monitoring AI systems and improving on them. It's also crucial in ensuring understanding, trust among its users, safety, its adoption, regulation, and compliance. What is important is that the users should not need technical expertise to understand what the AI is doing. The main areas of XAI: reliability, privacy, fairness, usability, causality, trust, and transparency. And in transparency, we mean disclosing everything about the model and its processes. These ensure responsible, ethical, and accountable AI deployment. So there are different types of XAI. The main techniques used for XAI are post hoc explanation, model transparency methods, counterfactual methods, and visualization. Two main areas are why an AI system made a specific decision, which is referred to as local, and what influences the AI system's behavior in general, referred to as global. For post hoc, we have sharp and lime. For sharp, which is shapely additive explanation, it explains how features of the data influence the model's decision. So in healthcare, age, symptoms, lab results will be examined for their influence on diagnosis in general. For line, which means local interpretable model agnostic explanations, explain how an individual prediction was made. So in healthcare, it will clarify why specific diagnosis or risk score was assigned in a specific case. Visualization techniques provide an intuitive representation of the model's behavior in charts, graphs, etc. And with interactive visualization, you go one more step. Data can be manipulated to observe real-time changes in model predictions. For counterfactual methods, users are able to use what changes in the input will produce which different outputs or results. So let's look at the applications of XAI in different industries. In healthcare, AI systems are increasingly being used for diagnosis and medication recommendation. Imagine presenting at the hospital with an illness, and an AI system recommends only a painkiller medication. You and the doctor would like to know why the conclusion was made. In finance, the challenges with AI are already happening when loans are declined and there is no reasonable explanation. XAI is needed to inform users and the affected parties about the cause of the denial. There are many more explanations. XAI enables understanding of AI systems, and it is at the core of trust for AI systems. In all these, real human lives are involved and could mean life or death in some cases. So to enhance XAI, we need to disclose information about the data and processes around data collection and model training. We should prefer simpler interpretable models to complex models as much as possible. The collaboration of AI developers, domain experts, ethicists, psychologists, sociologists, and end users, including other disciplines, is crucial. Regular auditing of AI systems will help reveal issues and improve on them and make them more trustworthy. So for the future, in conclusion, there are still challenges, even though a lot of process or progress is being made. Context-aware XAI techniques should be pursued to ensure explanations are tweaked for the end user in context to ensure the usefulness of the explanation. Thank you.